right, here's what I want your periodic table to look like. You guys are going to get a blank black and white one. The first thing I want you to do is add somewhere on your periodic table. I put it in the top left corner, but indicate that there are 18 groups and 7 periods. Okay, 18 groups, and then I put these vertical lines next to it to indicate that our groups are going up and down on the periodic table. Like here's group 1, this is group 2 going up and down, group 3, and so on, and then our last group 18 way over here. Okay, so the groups go vertically. And then our periods, I have 7 periods and then these horizontal lines just because your periods go this way. Okay, so the first period only has hydrogen and helium in it. The second period, third period, fourth, all the way down to our 7th period. And we only have 7. Technically, these bottom 2 are still classified as the 6th and 7th period because this is where they come from. They're just snipped out and put down below so we can fit this all nice and neat onto this piece of paper. But what you'll do is, like I said, put in the top left corner that you have 18 groups and 7 periods. Once you get that written in there, create a little key on the top. So throughout the periodic table, you're going to run into metals, metalloids, which are they have properties of both the metals and the nonmetals, and lastly our nonmetals. And so what I want you to do is write those 3 terms up on the top, and then we're going to pick 3 different colors to choose for labeling these. For me, I'm going to have my metalloids be this color here, and I'll show you where we put the metalloids. I'm going to start with the metalloids just because they split the periodic table nice. So here's our first metalloid. It's boron. So I'll highlight boron there. After that, we're going to go down to our next period, period 3. And in period 3, we have silicon as our metalloid. And the coloring doesn't have to be perfect, but make sure you can still see the element. If whatever you're using to color is going to cover it too much where you can't see, then just outline it. Okay, so then just go around it kind of like that. And that leads me to our next 2, which would be germanium and arsenic. Okay, so those are our metalloids. They have properties of both metals and nonmetals, also known as semiconductors. And the nice thing is everything to the right of the metalloids now are going to be classified as nonmetals. So I'm going to go ahead and choose a light blue option for my nonmetals and go down the stair-step line. I'm not highlighting oganesson there 118 just because it is an unknown. It has unknown properties. As of right now, we don't classify it as a metal. On the left side, don't forget, there is one other nonmetal over here, and that would be hydrogen. Let's label our metals. I'm going to go with a yellow highlight. It's going to be everything else except for a few of these unknowns down here. So right off the bat, I'll just go over the unknowns so I don't accidentally color those in. If you do happen to color them in, not a huge deal. Maybe in a few years we'll learn more about their properties and then classify them as likely a metal, but not a huge deal right now. Seven, the lanthanides and actinides, the ones that got snipped out, these are also going to be metals. All right, and there's our complete periodic table with our metals highlighted in yellow, metalloids in that lighter brown, and the nonmetals in the light blue. Another thing that we'll eventually put on our periodic table is how many valence electrons each group has. Group number 1 would have 1 valence electron. Group 2 would have 2 valence electrons. Group 3 and all these transition metals, they don't really follow, groups 3 through 12, they don't really follow a particular pattern. So some of them have, you can kind of see the valence electrons there. Some of them have 2, some of them have 1, some have 2. Okay, so they don't follow that nice pattern. But when you go into group 1, you can see, if you zoom in, 1 valence electron, 1, 1 all the way down. Group 2 would have 2, 2. These are indicating how many electrons are in that outer shell. As you can see, the further you get down, you can see the electrons in the other shells, but what we're looking for is the valence electrons, the one in the outer shell. And so that's why group 2 is all going to have 2s. Group 13 is where the pattern picks up again. So group 13, now you're going to see 3, 3. Go down, you should see 3, 3, and so on. These are 3 valence electrons in this group. Group 4, these would have 4 valence electrons. If you look in there close, yes, 4, 4, 4, all the way down. Group 15 has 5 valence electrons. Group 6 would all have 16. Group 7 would have 17 valence electrons. And group 18 would have 8, except for helium, which technically fills that outer shell with just 2 valence electrons. Because remember, that very, very first shell around the atom can fit 2 electrons in it. Helium's got the 2, 8, 8 for the rest of them. All right.